Have you ever gazed up at the night sky and wondered, where did it all come from? This question has puzzled humanity for ages, leading us on a quest for answers that takes us back to the very dawn of existence, the birthplace of stars, galaxies, and the cosmos itself. The most widely accepted explanation for this cosmic question is a mind-boggling event of epic proportions. The answer, my friends, lies in a concept known as the Big Bang Theory. The Big Bang Theory, in its simplest form, is like a cosmic explosion. Now, I'm not talking about dynamite in a tin can, but rather an explosion of such magnitude that it gave birth to the universe itself. Picture this. Approximately 13.8 billion years ago, a colossal explosion occurred. This wasn't your everyday firework display, it was a cosmic event that marked the birth of our universe. Imagine an extremely hot, dense point, far smaller than a pinprick. This point contained all the matter, energy, space and time that would eventually make up the universe we inhabit today. Then, in an instant, this point exploded. It expanded at an incredible rate, spilling out matter and energy, creating space and time as it grew. This event, the Big Bang, was not an explosion in space as we know it, but rather an explosion of space. It was the creation of everything from nothing, the beginning of existence as we understand it. The galaxies, stars, planets, and even the empty space between them all came into existence after this cosmic explosion. In the blink of an eye, the universe grew from smaller than a single atom to larger than a galaxy. And it's still expanding even now, billions of years later. In essence, the universe as we know it sprung into existence from an unimaginably hot and dense point. So if the universe started with a bang, what happened next? In the moments following this colossal explosion, the universe was a hot, dense sea of particles and energy. As it began to cool, it also started to expand, a process that continues even today. Picture this. The universe in its infancy was like a piping hot bowl of soup, brimming with protons, neutrons and electrons. As this cosmic soup cooled, these particles began to combine, forming hydrogen and helium atoms, the simplest elements in the periodic table. This process was a bit like the condensation of steam into water droplets, only on a cosmic scale. Now fast forward a few 100 million years. With the formation of atoms, the universe was no longer a formless fog, but a cosmic stage set for the next act, the birth of stars. These stars, with their immense gravitational pull, began to cluster together, forming galaxies. But here's the twist. The universe didn't stop expanding after the Big Bang, it's still expanding today. Think of it like a loaf of raisin bread baking in the oven. As the dough rises, the raisins, or in our case the galaxies, move further apart. And this, my friends, is one of the key pieces of evidence supporting the Big Bang Theory. Our universe, with its billions of galaxies, is the result of this ongoing cosmic evolution. All of this sounds fascinating, but how do we know it's true? Well, the Big Bang Theory isn't just a captivating story, it's supported by a wide array of compelling evidence. Let's delve into a few key pieces of this cosmic puzzle. Firstly, there's the cosmic microwave background radiation. After the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, light was finally able to travel through space. This light, now stretched into microwaves, fills the universe almost uniformly and is a snapshot of the universe about 375,000 years after the Big Bang. Next, we have the abundance of light elements. The Big Bang Theory predicts that the early universe was hot enough to create hydrogen, helium, and small amounts of lithium. When we look out into the universe today, we find these elements in the proportions predicted by the theory. Finally, there's the redshift of distant galaxies. As light from these galaxies travels towards us, the universe's expansion stretches it, shifting it towards the red end of the spectrum. This redshift is observed in all distant galaxies, suggesting that the universe is expanding in every direction, consistent with the Big Bang Theory. These pieces of evidence, among others, strongly support the Big Bang Theory, helping us unravel the mystery of our universe's birth. Yet, even with the Big Bang Theory, many questions remain unanswered. We are left pondering about the catalyst of the Big Bang itself. What sparked this colossal explosion? We question the existence of something, anything, before the Big Bang. Was there a prelude to the universe as we know it? And we wonder about the realms beyond our observable universe. What mysteries are they hiding? As we continue to explore and understand, perhaps one day these questions too will find their answers in the stars above.